Our goal is to find a formula and identity for the sine of theta over 2. I'm going to start from the version of cosine of a double angle that has the sine in it. So that's 1 minus 2 sine squared x. The next thing I'm going to do is solve for sine squared x. I'm going to get that sine squared x by itself. So if we rearrange the terms, I have 1 minus cosine 2x equals 2 sine squared x. That works out right with the signs. And now I'm going to divide each term by 2. So I got 1/2 minus 1/2 cosine of 2x equals sine squared x. Now I'm going to notice that if I put x over 2 in here, and that means I'm going to have to put x over 2 over here. Now I have, nothing happened to the constant out here. That's still 1/2 minus 1/2 cosine, well, 2 times x over 2, that's just x, equals sine squared of x over 2. We're almost there. The goal was the sine. I have sine squared. How do you go from sine to, or how do you go from sine squared to sine? You unsquare, you take a square root. So the sine of x over 2 is the square root of 1 minus cosine x. Since there's a common denominator there, I'm going to go ahead and just put them together over the common denominator. The other thing to recognize is that when we take a square root, I could end up with either the positive square root or the negative square root. This is not like in the quadratic formula where we're going to do both of them. And it's not that we're just going to pick one. We're going to pick either positive or negative. So it's only one or the other. X over 2 is a definite angle, and its sine value is either positive or negative. We're going to pick according to what quadrant that angle x over 2 is in. So if x over 2 is in quadrant 1 or quadrant 2, I'm going to pick positive because sine values are positive in 1 and 2. If x over 2 is in quadrant 3 or quadrant 4, I'm going to pick negative because the sign is negative there. For the cosine of a half angle and the tangent of the half angle, the process is very similar. We're just starting with the other two versions of the cosine of a double angle formula.